360 kilometers per hour. That is the top speed the new 2026 cars hit during preseason testing. Now here is the terrifying part. If the battery runs out at the wrong moment, that same car suddenly drops to around 300. And the car behind, with full electric boost activated, can still be doing 350 to 360. That is a 60 km per hour closing speed. Into a braking zone. Max Verstappen has called it anti-racing. He says it feels like managing spreadsheets instead of attacking corners. He warns that if this is the future of Formula One, he does not see himself staying long-term. The FIA says there is no panic. But they already introduced emergency technical directives. They banned low drag mode at the start. They restricted the overtake button. They installed automatic fail-safe systems on active aero. All before the first race. So here is the real question. Did the 2026 regulations just create the most dangerous speed differential in modern Formula One history? Or is this the painful birth of a new era the sport refuses to abandon? Stay with me, because what Verstappen revealed after preseason testing could force the FIA into the biggest decision of this generation. Now that preseason testing is over, the data is no longer theoretical. We have real numbers, real driver feedback, real warnings. And when you break down what actually happened in Bahrain, the picture becomes far more serious than a few frustrated comments. Under the new 2026 regulations, the balance of power has shifted dramatically toward the electrical side of the power unit. The electric motor now delivers 350 kilowatts of boost. The internal combustion engine produces less peak power than before, which means straight-line performance depends heavily on battery deployment. And that is where the instability begins. Because once that battery reaches its deployment limit, the car does not gradually lose a few kilometers per hour. It drops aggressively. Drivers reported scenarios where a car that had been accelerating strongly suddenly plateaued at around 290 to 300 kilometers per hour once clipping began. Meanwhile, a chasing car with full battery and the manual override system engaged could still be accelerating past 350. That is not a small difference. That is a 60 km per hour closing speed. And at those velocities, reaction time disappears. George Russell described it as chasing a moving wall. Verstappen described it as artificial racing. But the concern goes deeper than just overtakes. It is about predictability. In previous eras, you could judge a rival's speed by visual cues. Now you cannot see battery percentage. You cannot see when clipping will begin. You cannot instantly know whether the car ahead is lifting to harvest energy or preparing to brake. That uncertainty creates hesitation. And hesitation at 360 km per hour is dangerous. The FIA understands this. That is why, despite publicly saying there will be no major regulatory changes before Australia, they implemented immediate technical directives. Low drag active aero mode is now banned at the race start to prevent chaos into turn 1. The manual override system has been restricted so it only activates when within 0.8 seconds of the car ahead. Torque delivery is being monitored to prevent extreme spikes that could destabilize traction. And most importantly, a fail-safe mechanism has been introduced. If the active aero system fails, the wings automatically return to maximum downforce. That is not a minor adjustment. That is an emergency safeguard. Because there was a genuine fear. If a rear wing remained stuck in low drag mode at the end of a straight, the car would arrive at a braking zone without sufficient downforce. At 360 km per hour, that scenario is catastrophic. Then there is braking. With heavier reliance on regenerative systems, the mechanical brake components are smaller than before. If regeneration cuts out because the battery is full or overheated, the driver is suddenly relying on reduced mechanical braking capacity. One driver reportedly said that if you lose regeneration at the end of the straight, you become a passenger. That is not exaggeration. That is physics. And this is where Verstappen's comments carry real weight. He is not simply complaining about driving style. He is questioning the direction of the sport. He says racing should not feel like accounting. It should not revolve around calculating delta V and battery percentages every lap. He has openly stated that enjoyment matters more to him than statistics. He does not need 7 titles. He does not need to chase records. If the sport feels artificial, he has the financial freedom and contractual options to walk away after 2026. There is an active performance clause for 2027. If he is not within the top 2 of the championship by the summer break, he can exit. There is also the Helmut Marko clause, a political escape route if the internal structure of Red Bull changes. So this debate is not isolated. It connects regulation, safety, identity, and the future of the sport's biggest star. Australia will now serve as the first true stress test. Not just for competitive balance. For the concept itself. If we see dramatic speed differentials on long straights, if drivers are forced into excessive lift and coast phases, if instability appears under crosswinds due to extreme low drag setups, the pressure on the FIA will escalate instantly. Because fans can tolerate innovation, they cannot tolerate unpredictability that looks dangerous. The governing body believes the chaos is temporary. They argue that teams will refine energy mapping. They insist that sustainability and spectacle can coexist. But pre-season testing revealed something undeniable. The 2026 cars are brutally fast and brutally sensitive. When the battery is full, they are rockets. When it clips, they are vulnerable. That contrast is the core problem. And until race conditions prove otherwise, the question remains hanging over Melbourne. Did Formula One just push innovation too far, too fast? Or is this simply the painful beginning of a new era that drivers must adapt to? The lights will go out soon. And when they do, theory ends. Reality begins. And here is where the pressure truly begins to build. Because once the cars leave the controlled environment of testing and enter a real race weekend, variables multiply. Fuel loads change. Track evolution changes. Wind direction shifts. Drivers push harder. And most importantly, they stop managing for data and start fighting for position. In Bahrain, teams could choose when to deploy. They could plan battery usage lap by lap. They could avoid traffic. In Melbourne, that luxury disappears. Now imagine lap 5 of the race. 2 cars fighting for 4th place. The driver ahead has already used aggressive deployment defending on the previous straight. His battery percentage is low. He begins to lift slightly earlier than usual, preparing to harvest energy. The driver behind, sensing opportunity, activates manual override. He is gaining at an alarming rate. From 350 to 360 kilometers per hour. The car ahead is now hovering near 300. That closing speed is not theoretical. It is measurable. And it happens in seconds. Now add another layer. Crosswind. With reduced drag configurations required to reach those top speeds, the cars feel lighter in straight-line stability. Drivers reported during testing that the steering becomes extremely sensitive at maximum velocity. A gust of wind at 360 km per hour can shift the car meters sideways. That movement, combined with a 60 km per hour closing rate, creates a narrow window for decision-making. And then comes braking. From 360 down to under 100 for a heavy corner. The new generation depends heavily on regenerative braking to assist deceleration. If regeneration is limited or cuts out, the smaller mechanical brake discs must handle more energy than they were primarily designed for. The margin shrinks again. This is why the FIA implemented the fail-safe protocol. If active aero fails, the system defaults to high downforce. If a driver forgets to deactivate low drag mode, geofencing will shut it down automatically before critical braking zones. If torque delivery spikes dangerously, it will be monitored and restricted. All of these changes remove part of the human risk factor. But they also remove part of the driver's control. And that is where Verstappen's frustration connects to a larger theme. He is not just talking about safety. He is talking about identity. Formula One has always been about pushing limits. But traditionally, the limit was mechanical. Grip, braking, throttle control. Now the limit feels digital. Battery percentage, deployment maps, software thresholds. He argues that when a driver must constantly calculate energy flow instead of attacking corners instinctively, something fundamental changes. And that change could redefine the relationship between driver and machine. The FIA's official position is clear. No major regulation changes before Australia. The evidence is still considered early. They believe teams will adapt quickly. They believe the spectacle will improve as software and strategy stabilize. But internally, they already prepared an emergency power reduction plan. If Australia turns chaotic, electrical deployment during races could be limited to reduce extreme delta speeds. That possibility alone shows the seriousness of the situation. Because mid-season regulatory adjustments create competitive imbalance. Some teams optimized aggressively around electrical boost. Others struggled with energy mapping. If deployment is reduced, the hierarchy shifts. And championship narratives can change overnight. This is why Melbourne is not just another season opener. It is a referendum. On the 2026 philosophy. On whether sustainability-driven innovation can coexist with traditional racing instincts. On whether 60 km/h closing speeds can be managed safely in wheel-to-wheel combat. And beyond all of that, there is the Verstappen factor. He has already hinted that enjoyment matters more than records. He has contractual flexibility for 2027. He has openly criticized what he calls artificial racing. If the opening races reinforce his concerns, the pressure does not remain technical. It becomes political. Because losing the face of the sport over regulatory philosophy would be a seismic event. So when the lights go out in Melbourne, watch closely. Not just for overtakes. Watch for lift and coast patterns. Watch for sudden speed drops at the end of straights. Watch how aggressively drivers use override. Watch whether braking zones feel chaotic or controlled. Because if the delta speed issue appears under race pressure, the debate will explode instantly. And if it does not, the FIA gains validation for its vision. Either way, the first Grand Prix will not just decide points. It will decide whether the 2026 era begins with confidence or with crisis. And this is where the consequences stretch beyond one race. Because if Australia exposes even a single dramatic incident caused by delta speed, the reaction will be immediate. Not just from drivers, from teams, from broadcasters, from fans who suddenly see cars approaching each other as if they belong to different categories. Imagine a replay. One car visibly slowing at the end of the straight, energy clipped. Another arriving like a missile, 60 kilometers per hour faster. The overtake looks spectacular. Until you realize the driver ahead had almost no control over the situation. That is not a pure racing move. That is a system imbalance. The FIA believes this imbalance will shrink as teams refine their software. They argue that early chaos is natural in every regulation reset. In 2014, drivers complained about hybrid complexity. In 2018, they criticized the halo. Eventually, both became normal. But here the core difference is speed differential at extreme velocity. 360 down to 300 is not subtle. It is violent. And violent transitions demand trust. Right now, that trust is fragile. Drivers have reported that in high-speed sections, especially with low-drag configurations, the cars feel light. Almost floating. Crosswinds exaggerate that sensation. Steering corrections become sharper. Now combine that floating sensation with unpredictable energy clipping. The driver ahead may lift earlier than expected. The driver behind may commit to a move assuming stable behavior. One misjudgment at those speeds becomes headline news worldwide. And the FIA knows it. That is why they implemented geofencing. That is why they restricted active aero usage in chaotic phases like race starts and safety car restarts. That is why the fail-safe system forces maximum downforce if something goes wrong. They have effectively removed part of the driver's freedom to protect the system. But here lies another tension. When you remove freedom, you remove part of what defines Formula One. Risk management used to belong primarily to the driver. Now it belongs increasingly to software. The car decides when it is safe to run low drag mode. The system decides when override is allowed. The ECU locks configurations automatically. It is safer, but it feels less human. And that feeling is what Verstappen keeps pointing at. He is not arguing against sustainability. He is not rejecting innovation. He is questioning whether the racing instinct is being diluted. When he says he does not need to be here, it is not a threat for attention. It is leverage rooted in independence. He has titles. He has wealth. He has opportunities outside Formula One. Le Mans. Endurance racing. A different challenge. If 2026 turns into a season defined by battery management rather than wheel-to-wheel combat, his exit becomes realistic. And that possibility alone increases pressure on the governing body. Because losing the most dominant driver of the current era over regulatory philosophy would damage the credibility of the transition. Now zoom out. The FIA wants sustainability. Manufacturers want relevance. Teams want competitive balance. Drivers want authenticity. Fans want excitement without artificiality. All of those goals must coexist inside a single car traveling at 360 kilometers per hour. That is the impossible equation of 2026. Australia will not solve everything. But it will provide the first real answer. If the race unfolds smoothly, if overtakes look controlled rather than chaotic, if delta speeds appear manageable, the narrative shifts toward acceptance. If we see extreme lift and coast. If we see sudden slowdowns mid-straight. If we see instability under braking because regeneration cuts unpredictably. Then the emergency plan may move from backup option to immediate necessity. And once you activate a mid-season power reduction patch, you admit the concept needed correction. That admission changes everything. So the next chapter is simple. The cars line up. The batteries are full.